My name is Haylea, and I looked at the application of photosynthesis and bio-based ionic liquids through a metathesis reaction. So ionic liquids are salts that are made up of anions and cations, and they have a melting point of less than 100 degrees Celsius. And they have different physical and chemical properties that allow them to be very flexible and tunable. And a lot of research has shown that different anions and cation combinations can create different ionic liquids. And this helped me form my research question of what anions and cations could be used to create a non-toxic ionic liquid. So I decided to use choline and tetramethylammonium for my cations. Choline is cheap, biodegradable, and non-toxic, and tetramethylammonium is soluble in water and methanol, but it is toxic, so I was trying not to use it. For my anions, I use methyl orange and methyl red. They're azobenzene based, so they have the double nitrogen bond, which allows them to be both cis and trans, and they interconvert when exposed to different light at different wavelengths. I also use dipicolinic acid. A previous study used picolinic acid using an anion exchange resin, and then another study used choline chloride and amino acids. So I decided to try this process with dipicolinic acid. For my methods, I combined choline and methyl orange. I placed methyl orange and sodium hydroxide pellets in this flask, and I placed choline chloride in this bottom flask, and I let it drop to the bottom flask, and then it was stirred and a vacuum was placed, and this was done overnight. I also combined choline and methyl red, so potassium hydroxide, absolute ethanol were added to a flask with methyl red in it, and then it was choline chloride was later added, and it was centrifuged for 10 minutes, and then the liquid was pipetted out. Then it was placed in the rotary evaporator, and then later it was placed on a hot plate, and the temperature was slowly increased. I also combined choline with dipicolinic 1-. And so I weighed out the dipicolinic acid and choline chloride and placed it into a beaker, and then potassium hydroxide pellets were added until the pH reached 2.16. It was then placed in a vacuum oven overnight, and 30 milliliters of ethanol was added, and then it was placed back in the vacuum oven. I did the same process with choline dipicolinic 2-, except I added potassium hydroxide pellets until the pH reached 6.92. And then for the last one, I combined tetramethylammonium with dipicolinic. So tetramethylammonium chloride and potassium hydroxide were weighed out, and methanol was added. It was then heated at 60 degrees Celsius for 3 hours, and the liquid was then pipetted out and centrifuged. And then later dipicolinic acid was added, and then the rotary evaporator was used, and then it was placed in a vacuum oven. So for my results, I found that I created a dry orange powdery-like substance when I combined choline chloride with methyl orange. I also used DSC to find the melting points, and it had a melting point of 75 to 85 degrees Celsius. For the methyl red and choline chloride, it also had a melting point of 75 to 85 degrees Celsius, and it was a red solid-like substance. For the choline and dipicolinic 1-, it was a crystal-like dry substance, and when it was exposed to the atmosphere overnight, it became a liquid, so it's very deliquescent. And this could be it just absorbing moisture from the air. But it had a melting point of 70 degrees to 80 degrees Celsius. Choline dipicolinic was a clear solid, and it had the same melting point of 70 to 80 degrees Celsius, and it was also very deliquescent. For tetramethylammonium and dipicolinic acid, it was a clear solid, and no melting point was able to be obtained because it instantly turned into a liquid when it was exposed to the atmosphere. And then for my results, I used NMR to look at the integration of proton peaks, and then these are examples of the DSC I use. This is dipiclinic acid 1- and dipiclinic 2-. So it is possible that the substances created were ionic liquids because they all had melting points of less than 100 degrees Celsius. However, it could be that the dipiclinic acid with cholium and tetramethylammonium just absorbed moisture in the air, so it's not actually an ionic liquid. But there is a chance that the cholium combined with methyl orange and methyl red did turn out to be an ionic liquid. So further research could focus on characterizing the products and additional thermodynamic data on possible phase transitions. NMR was used to look at the integration of proton peaks to see if there was a 1-to-1 ratio, and this raised a question of if it was an actual 1-to-1 ratio. So I would like to further look at that. Further research could also test the conductivity to see if there is actually an ionic substance.